So I'm going over adding and subtracting rational expressions today. So in order to go through the material today, I'm making an assumption that you have at least gone through some of the previous material. Now, some of you may not have had a chance to do that yet, so just keep that in mind. So if there's something that you aren't quite following, that is not, like factoring, for example. You need to be able to do factoring in order to add and subtract rational expressions. Now, since this video isn't teaching factoring, I'm not going to go into the details of factoring. So if you aren't sure how to do factoring, or that's something that you haven't gone through yet, just accept what I do. And then what you can do after the session is watch the videos on factoring. And then what I would recommend doing is maybe re-watching this again after you've gone through factoring so that you have an understanding of what's going on. Another skill that we do here is simplifying rational expressions. So there is a video in the class on that. So that's another one that if you haven't watched that yet, some of this may not make entire sense yet, but you can watch that video later and then come back and re-watch this. So that's sort of how, because if I try to teach everything that you need, like this is already probably going to be a long video. That would be way too much time to try to do factoring and simplifying and also adding and subtracting rational expressions. So that's how this is going to work out, basically. So if you do have questions, you're welcome to interrupt me at any time. Just if it's a question on factoring, if it's quick, I can probably answer it. Otherwise, I might say, okay, watch my factoring video. And let's see. So Jen asks, if I've never done any algebra, is there a resource you know of I should check out to bring me up to date? So I posted, actually, let me bring up the classroom and I'll just show you guys. I gotta remember which tab I'm in. I've got multiple things open. So I'm going to just click on one of my college algebra questions here. And then I'm going to make sure that edit mode is off so that you don't see. So that way you see exactly what you should see. Okay. So okay. If you go to weekly content, I recorded a video on week 1. So if you go to the week 1 prerequisites and review, so I added this video yesterday. It's the week 1 introduction, and I go into specific details about what you need to know for week 1. In this video, I have provided links to outside resources if you really haven't done algebra before. So that way there's extra outside resource to help you get to where you need to be for this week. So you can also download the PowerPoint, and then you can click on those links directly. So if you haven't watched this video, you can watch it or click on the PowerPoint, and then I have outside resources there. Also, in the supplemental materials, if I scroll down, you're probably going to want to check out the prerequisite material here. So I have a whole bunch of things like fractions, decimals, negatives. Algebra foundations would be very helpful if you've never done algebra before. These are a lot of basics here, and then you're probably going to want to also access the week 1 supplemental material, where there's a lot of additional links, like on order of operations. Our textbook doesn't go into details on the order of operations, so that would be something that you may need to study up on. So looking at some of these resources would be helpful as well if you haven't done algebra before. Before I get started, are there any other questions? I see a couple people are typing. Okay, yeah, if you've only done geometry, there's going to be a lot here that you may not have seen before, so you may have to do some extra work the first couple of weeks to get on track. Okay, and if you would like to set up a one-on-one with me, send me an email with your schedule so we can try to see where we can fit that in. That's the best way to set a one-on-one up with me, if you'd like to do that. So I'll schedule that. Look at you. You tell me. Make sure you tell me your time zone too. You know what days you're available, what times you're available, your time zone, whether you're in Eastern or Central or some other time zone, and then we'll try to figure something out. Are there any other questions before I go into the lesson?
I'm ready.
Okay. All right. So I'm going to start off with the least common denominator. And I'm supplementing all the stuff in this lesson with stuff, or the textbook doesn't go in a lot of detail on this stuff, which is I'm adding in a lot of things that are not in the textbook. So this is going to be much more helpful than actually just reading the textbook here. So in order to add or subtract rational expressions, and I should just, if you haven't watched any of the other videos, a rational expression is basically a fraction where you have variables in the denominator. So it could look like 2x over x plus 5. So that's what's a rational expression. The rule is you have to have a variable in the denominator. So if we're adding or subtracting these, we need to have a common denominator. That's the same rule if you're adding and subtracting fractions. So the rules for things without variables are the same rules when you have things with variables. So the same rules apply, we just now have letters involved. So when we have rational expressions, the common denominator is the least common multiple of the denominators. So the mathematical definition of the least common multiple is the very, very mathy definition. The least common multiple is defined as the smallest positive number m for which there exist positive integers na and nb such that na times a is the same as nb times b, and that equals m. So to kind of show you or explain what that mathematical definition means is if I have, let's see, I'm trying to think how to, we want the least common multiple, so like 2 times 12, and I'm trying to think how to demonstrate this. So 2 times 12 is 24, and 6 times 4 is equal to 24. So the least common multiple is 24, essentially. If you're looking at two numbers, 12 and 4, say. If you're trying to find, well, actually, that wouldn't even make sense. Those are not least common multiples. This is what I get for trying to think of an example on the fly. So basically, I'll just try to explain it in words, basically. So the least common multiple.
How about 3 and 8?
There we go. Okay, those are better. See, I happened to pick two numbers that already had something in common. I picked, so 3 and 8. Yeah. So the least common multiple between 3 and 8 is 24, because 3 times 8 is 24, and 8 times 3 is 24. Whoops, not 12. 24. And 24 is the smallest number they both have in common if you were to make their multiplication tables. So the least common multiple. So it is a number that's a multiple of what you started with, which means it's going to be bigger than your original numbers, but it's the smallest one they have in common. It's a really confusing definition because you're looking for the biggest, a number that's bigger than what you started with, but it's the smallest in common, so it sounds kind of contradictory. So if you were to make multiplication tables, it's basically the smallest number that would show up on both of their multiplication tables. If you're doing a multiplication table of like 3 and a multiplication table of 8. So that would be the smallest number in common on both of those. So when you're doing a common denominator, you want your common denominator to be the least common multiple because you want it to be the smallest number you can use because it's easier to work with. And so they call that the least common denominator. Now I'm going to go over just finding the least common multiple of numbers in two different ways. So there are multiple ways to do this. If you know your multiplication table, you can say, okay, like if you're familiar with fractions and you have numbers like 3 and 8, you can say, okay, I know that they both have 24 in common, and you can use that. Otherwise, you can create an actual multiplication table to find out what they have in common. Or you can do prime factorization. And I do talk about prime factorization in the video about simplifying radicals because we use that method. So I'm going to just write that here. P.2. Specifically, if you watch my live session video, not the video in the weekly content, but the one in the live area, it goes into much more detail on simplifying radicals, and I talk about prime factorization there. And so you can do prime factorization, and then you pick the factors that are in common with the largest exponents, and I'll demonstrate these methods. So I believe the best way to illustrate this is just with an example. So I've got two numbers here, 12 and 30. The least common multiple is going to be a number that is bigger than 12 and 30, that they can both multiply to in some way. Or another way to think about it is this least common multiple, 12 and 30 both divide into it evenly. That's another way to think about it. So I'm going to start with the multiplication table method. So when you're doing your multiplication tables, you have what you're multiplying by going across. And then you'll have like your number on the left. And this is like going way back to elementary school if you ever had to fill in the table. And you always multiply the row by the column. So I'm going to just I'm going to use this little star here to represent multiplication. I don't want to put an X and be confusing. So when you fill in a multiplication table, you're just multiplying the row times the column. So like 12 times 1 is 12. Then 12 times 2, 24. 12 times 3 is 48. Nope, that's 12 times 4. Hi, apparently this is a Friday.
36.
36, 48. 12 times 5, 60. Then we've got 72, and then 84. So you can keep going and make your multiplication table. And then you would also do a multiplication table with the other number, 30. So I'm also going to make my multiplication with 30. So 30 times 1 is 30. 30 times 2 is 60. And when you get to the first one that they have in common, so that is the first one they have in common, that is your least common multiple. So you make a multiplication table, and then you look for the first number that shows up in both tables. So the least common multiple is 60. So if you had a fraction and your denominators were 12 and 30, you would have to build the fraction up so that the denominator was 60 so that you could add those together. Now moving to the prime factorization model. So the way that I do prime factorization is I make what I call a factor tree. So I start with one of the numbers. 12. And I just split it up into two numbers that multiply to 12. And it doesn't matter which set of numbers that you do. You can do whichever one comes to your head. But 3 times 4 comes to my head first. 3 is a prime number. There aren't things that multiply to 3 other than 1 and 3. So I'm going to circle that. But I can split 4 up. I'm going to try to split 4 up, and that's 2 times 2. And then 2 is prime because there's nothing that can multiply to 2 other than 1 or 2. And so I circle those. So the prime factorization of 12 is 2 times 2 times 3. And since I have 2 written twice, I'm going to write that as an exponent. That's 2 squared times 3. Yeah, Frederick, do you have a question?
Yes. Why are you using dots as times?
We use the dot as multiplication because the x is reserved for a variable. So we will never, when you get to algebra, you never use an x to represent multiplication. The symbol that we use is always a dot.
All right. Thank you very much.
You're welcome. So I've written 12 now as 2 squared times 3. And I'm going to do the same thing with 30. So 30 is, I can do 3 times 10. 10 is prime, so I'm going to circle that. I can split 10 up as 2 times 5. And then those are both prime. So 30 can be written as 2 times 3 times 5. So now those are the prime factorizations, and to find the least common multiple, you compare them. So I compare them number by number. So I have a 2 in the 30, and then I have 2 squared in 12. So they both have 2 show up on their table, basically, their prime factorization. And your least common multiple has the one with the highest exponent. So it's like you're picking from one of these, and you take the highest exponent. So our least common multiple is going to include 2 squared. Then you compare the next number, 3. 3 shows up in both of them, and it only shows up once. So I'm going to have 3 show up in my least common multiple once. It doesn't matter which one I highlight. So let's say I just highlight that one. So I'm going to have times 3. And then I have a 5 show up in one of my prime factorizations, but not the other one. So I want to include 5 because I want to basically, if it exists, it needs to be in my least common multiple. So I'm going to include a 5 in my least common multiple. And so then you would multiply these. You'd have 2 squared, which is 4. And you would have 4 times 3 times 5. 4 times 3 is 12. 12 times 5 is 60. And you get the same number. You still get 60. It's just another method of doing this. So one method is by making a multiplication table. The other one is by doing prime factorization and then creating your least common multiple based off of the numbers that exist in your prime factorization. Are there any questions?
No question for me.
Okay, Brad, do you have a question?
Yes. So when we're doing this, it looks like for time, it would be a lot quicker using the table rather than the prime. Would you agree?
It depends on the numbers. For small numbers like 12 and 30, I would use the table. But sometimes if you have really big numbers, I personally find it easier to do the prime factorization method. But either one works. so you can use either one. I show the prime factorization method because that's the method you have to use once we start using variables. Because there is no multiplication table with variables. So it's important to know both methods because they're used basically in different situations.
Okay.
Are there any other questions? Okay. Oh, I see Jen is typing. Oh, just typing note. Okay. So moving on to finding the least common multiple when you have algebraic expressions. And algebraic expressions means that you have algebra, which means you have variables. So these are when you have things with variables and you're still trying to find what they have in common. So we have to use the same method as the prime factorization method. But instead of making a little tree like I did with numbers, we factor. So you factor each expression, and that comes from section P.3. So if you need to review P.3 or P.4, actually, let me grab my textbook to make sure I have the right section. There's so many sections we go through each week. P.4, okay. Yeah, I don't want to direct you to the wrong section. So that factoring is covered in P.4. And so you need to factor first, and then you choose each factor with the highest exponent. So the highest exponent part is in common with what we did with that the example on the previous slide, where they both have a 2, and I took the highest exponent. I picked that one. So it's the same concept. And I actually think finding the least common multiple with algebraic expressions is easier than finding it with numbers. So I've got 2 examples here. So on the first, on the left, I have 32x squared y and 20y cubed. So you kind of do this in pieces. So first you want to find the least common multiple between 32 and 20. So I'm going to just write this, least common multiple of 32 and 20. So you could choose to do the table method, or you can choose to do the prime factorization method. So do you guys, which method do you want to see me do?
I think we should try both methods, but the prime factorization method works well for me. I don't know
Okay.
about my other classmates.
I agree with both.
Do both? Okay. We can do both. And I figure if I have more things planned than we have time for, I can always do a second session and do a part 2. I've done that before. So I don't want to rush through things, you know, and because there's no reason to. So let's do both. And I don't think I have left myself enough. So I'm actually going to temporarily end this, and I'm going to split this up into 2 slides with each problem on a different slide so that I make sure I have enough room there. So just duplicate that. All right. So got that. That way we can have enough room. Okay. So table method. Whoops. I forgot to put my pen up. I will do this. So we have 20 and 32. And I'm going to just skip multiplying by 1 because multiplying by 1, I know they're not in common. So I'm going to do times 2. So 20 times 2 is 40, and 32 times 2 is 64. And then I'm going to do times 3. 20 times 3 is 60. And 32 times 3, according to my calculator, is 96. So then I'll do times 4, so that gives me 80 and 128. Times 5 gives me 100. Get 160. Times 6, 120. And I'm going to, I know that 160 is going to be the number that shows up eventually as the least common multiple. So I kind of saw where it was going, and I saw, oh, I got 160. I know based off of my pattern of multiplying by 20 that I'm eventually going to get there. So the least common multiple here is 160. So I'm not going to bother filling in the rest of the table, but you can. So, all right, LCM. So we know we're going to have 160 out of the number portions. Next, we want to look at the variables. So we're going to look at our letters. So I have x squared, and then I don't have x in the 20y cubed. So if it doesn't exist in one of the things, it has to exist because we're building something bigger. So if it exists in one of them, it has to exist in our common multiple. So since I have an x squared in at least one of the terms, I need to have x squared in my least common multiple. Then I'm going to compare the y's. I have y in one of them and y cubed in the second one. So if the letter exists in both, you pick the one with the highest exponent. So that's going to be y cubed. So that makes my least common multiple 160 x squared y cubed. Now if you want to do this, oh yes, question.
Okay, I guess my question is when I'm looking at this, what happens to the y, just the plain y? Because you've got...
We're building something separate from the two things that we started with. So we're not doing anything to what we started with. We're creating a third thing based off of these rules.
Okay.
So that y is still there. It's just, yeah, we're just, yeah, it's like you're creating a new word if you want to think about it that way.
Okay, got it.
Now I did say we're going to do both methods here. So I want to also do the prime factorization method to do the least common multiple out of 32 and 20. So I'm going to 32, we're going to just do up on the top right here. Whoops, not 38. Maybe I should not plan these for Fridays. So 32, I can split that up as 8 times 4. And 8 I can split up as 4 times 2. And 2 is prime, so I can circle that. And then 4 I can split as 2 times 2. So I'm going to circle those. And then I have this other 4 that I can split up as 2 times 2. So 32 I can rewrite as 2. And then I count how many 2's I have circled. I have 1, 2, 3, 4, 5. So that is 2 to the 5th. Now I want to do the prime factorization of 20. So I'm going to just go to the left. And 20 is 4 times 5. So 5 is prime, so I'm going to circle that. And then 4 I can split up as 2 times 2. And so then I can circle those 2's. So 20, I start with 2. There's 2 of them, so that's going to be 2 squared. And then I also have a 5. So if I want to find the least common multiple between these two numbers, I'm going to compare with the 2's. and I want the one with the highest exponent. So the exponent with 5 is bigger than 2. So my least common multiple is going to be 2 to the 5th. Rewrite that a little better. And then I go to the next one, and I can only build something new. I can't take away anything. So since there's a 5 existing, I need to have a 5. And so in this case, the least common multiple is 2 to the 5th times 5. And 2 to the 5th is 32, so that's 32 times 5. And you can see on our multiplication table that comes out to 160. So that matches the same number we got with the multiplication table. So that's the number in front, and then you look at the variables when you go back to your original. So to make it clear what your final answer is, I'm going to box it. The least common multiple of what we started with, 32x squared y and 20y cubed, is 160x squared y cubed. Is there any questions?
I think I'm okay.
Okay.
It's starting to dig in a little.
The best way for this to really sink in is to watch many, many, many examples. Of course, I can't sit here and do like 10 examples all day, you know. But what I would recommend doing, if you need more examples, is to just go on YouTube and, you know, maybe type in least common multiple of expressions and then see what pops up and just watch lots of YouTube videos. Or stick with the chart, yeah. As long as you see, this is why I teach multiple methods. As long as you know that there's a method that works for you, that you understand, go ahead and use it. Because it's like, yeah, go ahead.
And you can use the other method to make sure you didn't make a mistake.
That is true. The other method is a great way to check your answer. So use whatever method works for you, whatever you think is easiest. I don't believe in teaching only one method unless it's a case where there is only one method. Then there's no choice. But whenever possible, I try to show different ways to do it. Now, my second example here is actually going to be much easier than the other ones we've done so far. So this is factored for us. And when it's factored, you look at each factor. And a factor are the things in parentheses. So you look at the groupings of things in parentheses to see what is in common. So I'm going to write these vertically, sort of like I did with the prime factorization method, and just line things up. And so our least common multiple, we look at each group of parentheses. So yeah, Fred, if you have to pop out, if anybody has to pop out for whatever reason, go right ahead. That's why this is recorded. You can pop back in to view it again. And Jen used it easier as a relative term. This will be, believe me. Believe me, this one, you're going to be like, wait, that's it? So I've got these lined up, x plus 1 squared and x plus 1. So I'm matching up the things in parentheses. And I want the one with the highest exponent. So one has an exponent of 2, one doesn't have an exponent, so higher is 2, so I have x plus 1 squared. Then, next one, I have something without x minus 2, and then I have x minus 2. So I need to at least have it x minus 2, and that's it. That's your answer. You don't have to actually multiply it out. You don't have to do anything. That's all you do. So was I right in saying this one was easier? See, yeah. This is one case where having variables actually makes it easier than you're working with numbers. Because you're just literally pulling things from what you see and stringing them together. Do you guys have questions on this example?
Nope, I get it.
Okay, if it were all this easy. Well, my hope, Daniel, is that I do make it all easy so that you can pass the class. That's my goal. I'm going to try as best as I can. Okay, so now that we've done some practice, we're going to be looking at actually finding the least common denominator, because all we do is just practice the least common multiple. And we haven't actually done least common denominator yet, which will get us to rational expressions. So what these two examples are they're both containing rational expressions because there are variables in the denominator of the fraction. So the least common denominator is basically you do the same exact thing that we just did, but we just look at the denominator instead of the numerator. You ignore the tops of the fractions. You don't care. You only look at the denominator. So on the left, we have 1 over 2a and then 2 over 3b. So our least common denominator, and this is not going to be bad at all. So first we look at the numbers, 2 and 3. And we want the least common multiple of 2 and 3. If the numbers are prime, you could just multiply those together. So the least common multiple out of 2 and 3 is 6. And if with numbers, if you want to do that method, you could just multiply them, that will always work, especially with small numbers. You just have to reduce afterwards. Yes, Brad, I will have the PowerPoint available for download afterwards. So if you want to just watch and then take notes later by rewatching it or whatever, that will work.
I'll be doing both.
Yeah, whatever. Yeah, if you want to take notes and then double check your notes, whatever works for you.
That's what I'm doing.
So, so out of the numbers 2 and 3 in my denominator, the least common multiple is 6. So that's part of my least common denominator. Then I look at my variables. I have an a in one of them and not in the other one. So I need to have an a. And then I have a b in one of them and not in the other one. So I have to have a b. So my least common denominator is 6ab. So I could have lined these up like 2a, and then, well, 3 is not part of those, and b, because these are, if they're prime, I can line them kind of all up. My least common denominator is the least common multiple of these, 2 times a times 3 times b, and then you could just multiply 2 times 3, and that gets you 6ab. Now on the right here, this one's a little more complicated. I have 12 over x plus 2, and then I have x minus 5 over x squared plus 5x plus 6. So the first thing I have to do is factor. I have to factor anything that is not, if you have anything with like an x squared, you have to factor it in order to find the common denominator. So anything that's x squared or higher, you have to factor. So that's what we're going to do first. So we're going to factor x squared plus 5x plus 6. So if you need to go back to factoring, that's section P.4. So this is one that I can factor in my head pretty simple. I need two numbers that multiply to 6 and add to 5. So 2 times 3 gets me 6. 2 plus 3 gives me 5. And because I'm multiplying to a positive and adding to a positive, both of these have to be positive. So this leaves me with a factored version of x plus 2 times x plus 3. So now I'm looking at my two fractions. I have 12 over x plus 2, and then x minus 5 over x plus 2 times x plus 3. And so when I'm finding my common denominator, I'm finding the least common multiple. And so the first denominator we have is x plus 2. So, and if it doesn't have parentheses like that, you can always group it as having parentheses. So that's x plus 2. The second one is x plus 2, x plus 3. So then my least common denominator, which is the same as the least common multiple of the denominators. So when I'm comparing, I have an x plus 2 in both of them. They both don't have an exponent, so I just have an x plus 2 because it's present in both of them. And then I have an x plus 3 present in at least one of them. So that's going to be my common denominator. So in the second example, the second fraction already has what the common denominator would be. And if we wanted to add or subtract these, we would have to build the first fraction up to have that common denominator. But we're not going to do that just yet. Are there any questions? Yeah, Lewis.
Can you go over the part where you turned x squared plus 5x plus 6 into the x plus 2, x plus 3? Could you go over that part one more time?
Yeah, so factoring, when you have something that's an x squared, you are trying to undo a FOIL process. FOIL is talked about in P.5, where you're multiplying polynomials. Your goal is you're going to be multiplying, and I'm going to just use yellow. So FOIL means you multiply the first terms. So that's x times x, and that gets you x squared. Then O in FOIL stands for the outside term. So you multiply x times 3, that gets you 3x. And then the inside terms, you multiply 2 times x, that gets you 2x. When you add those, 2x plus 3x gets you 5x. So that matches with my 5x that I have that I started with. And then the last terms means you multiply 2 times 3, and that will get you 6, which matches what we first started with. So when we're undoing the process, we're looking for two numbers that multiply to the last number in the polynomial, which is 6, and also add to the number that's in the middle, which is 5. So that's how I came up with 2 and 3, because 2 times 3 is 6, and then 2 plus 3 gives me 5.
Awesome. Thank you so much.
You're welcome. Brad, did you have a question? I saw you raised your hand.
Yeah. I guess I'm kind of lost on here. So you got the x squared plus 5x plus 6. You got x plus 2 times x plus 3 is 6. It is x squared 6. And where does the 5 come from?
So here's, let me do this off to the side. We can do a multiplication table. So we have x plus 2, and I'm going to just make a table where my horizontal is x and 2. And then we have x plus 3, so I can make that the vertical. I have an x and a 3. So when we form a multiplication table here, I'm multiplying the first row by the first column. So x times x, that gives you an x squared, because there's now 2 of them. Then when you do x times 2, you're multiplying a variable by a number, and those just get attached together. So that gives me 2x. Then I multiply my second row by the column. So that's 3 times x. So those get attached together. And then 3 times 2 gives you 6. So when you multiply these, you get x squared plus 2x plus 3x plus 6, if it will show up. It's just being a little delayed here. And then we can add the 2x and 3x together because those are like terms. So that's how we get x squared plus 5x plus 6. So I am undoing that process, essentially, when I factor. And you can multiply it back out to double check that you factored correctly.
I guess my question is that we've got multiplication and addition in the same, and I'm in the same problem, and I'm confused on where you go addition, where you go multiplication.
Okay, so when we factor, we are always creating things with multiplication, and then there's going to be either addition or subtraction inside there.
And that is what the 3x and 2x are.
The 3x and 2x come from multiplying the different pieces that we have together.
Right. Okay, I've got that part.
Okay.
But that to me makes 6x. But you're saying it's addition, so it's 5x.
Right. Yes, because we're not multiplying 2x and 3x, because we have this other plus stuff going inside. I think, just trust me on this for now. I think what would help you is if you, let me show you, bring up my, if we go to the live sessions and instructor videos, I think watching the video on multiplication of polynomials will help with this.
Okay.
So if we just go to the week 1. So this one that I have that says polynomials and special products. This is where we go into multiplying polynomials near the end of the video, and I think that will help you. So you may have to, I recommend watching the entire video there. But I think that will help answer your question, as well as we're also going into adding and subtracting polynomials. So I think that will also help you with the 5x versus 6x thing.
Great.
So,
thank you.
Yeah. So just trust me for now, and then we'll do that.
Trust, but verify.
Yes, verify afterwards. And actually, now that I'm looking at the time, I have several slides, and I haven't even gotten to the actual fraction part yet. And I know that's going to take a while. So I think the best use, I think what might be best is actually split this up into 2 sessions. And do the actual adding and subtracting with these in another session. So I'm going to just take a quick look at my calendar.